Ooh.
Something going on. Yeah, yeah. Something going on in the neighborhood. Why do we see much further than we should? You're sick of the lies, sick of the lies. Who you gonna call when you get on the line? Who you gonna call? Who you gonna call? Who you gonna call? Yeah, Glowbusters! 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 There ain't no curve, there ain't no fall. The globe religion's about to fall. We're gonna open your eyes so you can see who you gonna call if you wanna be free. Glowbusters! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! Glowbusters! Glowbusters! Glowbusters!
And welcome everybody to Glowbusters.
We accept the reality of the world with which we're presented. It's as simple as that.
And welcome to Glowbusters Season 9, Episode 10, Etherwind, GPS, and Interferometry. Going to be a dope show. I am, of course, hosting, and I am Witsit, Austin Witsit. And we have a dope panel, awesome show. So we're going to get right into it and introduce everyone. So let's start off with Jaren from Jarenism. How's it going, my guy? And we will skip Jaren.
No, he won't skip me. Right with the mute button there. Doing fantastic. Thanks, Austin. How are you?
Good, man. Good. Thanks for
Great job your debate last night. I was watching that this morning. Enjoyed it.
thanks. I'm still exhausted.
Yeah, well, 4.5 hours isn't easy.
Yeah, it's crazy, man. Well, hopefully we won't have to talk about that too much. And next we have Zach from Good Times for All. Zach, how's it going, brother?
Hey, what's going on, Austin? Yeah, doing good. I've been wanting to hear this show for a while now. Really interested in the guest, and yeah, can't wait to hear what he brings.
Agreed. It is going to be awesome. All right. We also have Troubling Tribune. Thanks for coming, bro. How's it going?
Another day in paradise. Thanks for having me. I'm really excited to see the presentation from Space Audits. A good friend of mine has been in quite a few of my open panel debates, so very, very smart. And again, looking forward to the presentation.
Same. All right. And then, of course, without further ado, the guy who will be hitting us with a dope presentation today, my boy Alan from Space Audits. Alan, how's it going, brother? Thanks for coming on.
Hey, what's going on, man? I'm going good. I'm doing good. I'm excited to present the information I have. It's been a really fun discovery going through the process and learning everything, and I can't wait to share it with everyone.
Yeah, it's gonna be awesome. I've heard some bits of it, and Alan crushes. If you don't know, go to Space Audits on YouTube and show him some love. We'll be dropping his link throughout the show. We'll switch over to Rockfin an hour and a half in. We'll read all donations on YouTube and on Rockfin, and we will again be exclusively on Rockfin for the second half of the show. That's rockfin.com/globebusters. It's set to free, so no excuses. And cool. All right, so whenever you're ready, Alan, you can share the screen, and I'll throw it up for everyone.
Cool.
Cool. So yeah, while we get that, just so you guys No, again, it's about ether wind, GPS, and interferometry. Maybe one of the biggest tricks they pulled off was convincing people this is somehow verification of gravity in the globe and whatever. So looking forward to it. And I guess without further ado, unless anyone else has anything, we'll just jump right in.
Let's do it.
All right, I got the presentation up. Are you guys able to see it okay?
Yes.
All right, cool. So the working title so far is the Sagnac effect in GPS. And what we're going to learn about the Sagnac effect is that it's not due to any sort of rotational effect, which is, how they try to ascribe the effects within relativistic means. We're going to find that it's actually a linear effect and that it's dependent on the direction. So and that direction is faster than, or faster electromagnetic propagation going west to east, going east to west. And through the globe paradigm, they interpret it counterclockwise because, they think the rotation of the Earth is what's causing the sky or whatever. So anyway, referenced it backwards, but the electromagnetic propagation is faster west or east to west. So we'll continue on here. Now there's a lot of prerequisites to kind of learn through. So the way I have it presented is I'm going to cover like the broad aspects of what's going on, and then we'll break down, we'll just kind of build on everything as we learn, and then it'll all make sense at the end, and then we'll do a recap to tie it all together. So here's a summary of the arguments before breaking down the components. So there's a varying speed of c, and as we know from relativity theory, c is supposed to be invariant. It's supposed to be independent of the velocity or motion of the observer or the thing emitting the light source. So there's a varying source of c, which is shown through GPS, and that's done by using GPS's time interval system in a range measurement equation, which we'll get into later. And there's also a preferred reference frame to take these measurements in, which is another postulate violation of special relativity, because the preferred reference frame, which all this is measured in, is the ECI frame. So we'll get into what exactly all that means. And we'll get into the rules for transformations, so the general principles of covariance. And so basically all these transformations, you might have heard of like a Lorentz transformation, that sort of thing. So what these are referring to are you're swapping coordinate systems basically. And now there's rules for this when you're transferring things that are in regards to the laws of physics, and certain variables have to be what are called invariant transformations, meaning that the laws of physics can't change, right? So if it's the same in this coordinate system, it has to be in the same as the other to be in accordance with all reference frames being equally valid. So that's kind of the structure that we'll get into, and I'll explain further what that means moving forward, because we're going to see how GPS actually proves that there's a preferred reference frame and all that, and how that ties into it. And there's the principle of relative simultaneity, which we'll get into. They use that for, time dilation and stuff like that. So we'll explain how this is philosophically bankrupt and shown to be, in conflict with how GPS actually works. GPS's accuracy actually depends on special relativity's version of simultaneity not being true. So it's violated on all fronts. So here we have Einstein's paper where he talks about, in the abstract, he's, talking about how he came to his conclusion about these postulates, which are, the first postulate is that all inertial frames are equally valid and that there's no preferred reference frame. So mathematically speaking, he's saying that from a perspective where you're measuring relative motion, there's no an absolute reference frame would be, what does he say, verbosely superfluous or whatever. So that's what he's talking about. He's saying that from any reference frame, you could measure anything. And then in regards to, and also in regards to that postulate, he derived that from an interaction with a magnet in a conductor. So if you move a magnet over a conductor, it produces an electric field. If you move a conductor over a stationary magnet, it produces a repulsive field. So what he deduced from that is that, or his conclusion from that was that all inertial frames are equally valid, because no matter what reference frame you're in, if you're moving or not moving, there's still going to be an effect. So you'll either get the Lorentz force or you'll get the electric field. So that was his philosophical jumping off point for that, if you to try and tie together where Einstein's coming from on that. And then from that, he says that C is invariant based on his interpretation of the Michelson-Morley experiment. So 1887, they did the Michelson-Morley experiment where they were expecting to measure 30 kilometers a second, or I'm sorry, they were expecting to measure a fringe shift pattern corresponding to 30 kilometers a second. They had each fringe measure, or divided into 5 kilometers a second, and they got like just over one fringe. So they said that experiment was a null result, and it was due to instrumental error, and that what it actually proved is that the speed of light was the same. So that's where Einstein gets his second postulate, is off the misinterpretation of Michelson-Morley, that the speed of light is the same in all reference frames. So combining all that, they've got a mathematic structure where, as long as they can conform the coordinate system to the speed of light, they can make measurements and say that everything is the same in all reference frames, even without validating it, right? So to continue off of that, there's just kind of a summary, which I already laid out, of what I just said, explaining that. And with the Michelson-Morley stuff, let's see here. So a thing to note with the Michelson-Morley thing is that their measurement scale that they provided for the fringe shift patterns is a custom scale that they made to interpret the Earth's orbital velocity. No one's ever measured anything at 5 kilometers a second in the way that they're talking about. I'll get into that later with Michelson-Gale and the Sagnac effect. When they don't use that scale, they just have the same fringe shift pattern, and it shows a varying speed of light corresponding to the latitude. So like the further away you are from the ether vortex, that translation of motion of the vortex has a is what's giving the wind its speed, so to speak, or giving the light its speed boost, so to speak, and that's relative to the latitude, and that's all they've ever measured. So when you look into interferometry, you'll come across measurements, Dayton Miller's work and stuff, where it's through the lens of 5 kilometers a second. Keep in mind, it's without the scale, it's the same relevant to whatever the latitude would be for Earth rotation, so-called, right? So that's how that works with the scaling for the 5 kilometers a second. So no one's ever measured Earth's orbital velocity in any regard. So we'll come back to that. That'll be important later. Let's see, attributed Einstein comparison. Okay, we're looking good on everything on this slide. So just to sum it up real quick, I borrowed a couple slides from your girl, Professor Jody Cooley here. So she sums it up nicely. Einstein's postulates for special relativity. The laws of physics are invariant to observers in different inertial reference frames. And the speed of light is the same to all observers, regardless of their relative motion to the light source. Well said, Jody. Great summary, I think. So we got our summary of the framework moving forward, and now we're going to analyze the mathematics in terms of the transformations that they apply to verify this system here about these reference frames being all valid and stuff. So this is how that would be facilitated through the mathematics. So we have what's called Lorentz covariance, and this is built on relativistic physics is built on Lorentz symmetry, Lorentz invariance, and what that means is basically it's all the rules for transformations that I was talking about earlier in regards to the laws of physics. So in order for your transformations and everything to be covariant and be on the up and up, they must be Lorentz covariant. So you must have those laws of physics must hold true in every frame, right? So just read off here what that explains, and we'll keep going forward. An equation is said to be Lorentz covariant if it can be written in Lorentz covariant quantities. Confusingly, some use the term invariant here. The key property of the equation is that if they hold in one inertial frame, then they hold in any inertial frame. This follows from the result that if a component of a tensor vanishes in one frame, they must vanish in all frames. So if it's not equally valid in all frames, and if it's just in one, then it invalidates the whole system, is basically what that means. And so all the laws have to be the same when you transfer coordinate systems. So to recap on that, go over some definitions. So a reference frame is a mathematical presupposition described by a coordinate system using a defined set of axes, x, y, z, t. The position and motion of objects within that coordinate system allows you to describe the physical quantities and phenomenon within that reference frame by the coordinate system. Transform. To transfer information such as variables representing the laws of physics and other values other values to another coordinate system. In this case, this c, the speed of light, is a law of physics that should remain invariant under all transformations. Mathematically, the laws of physics are invariant under transformation between coordinate systems. This concept is known as invariance or covariance. So like I was saying earlier with the Lorentz covariance and the transformations, everything has to be the same in all coordinate systems, all reference frames. This means that the laws of physics must remain the same regardless of the specific coordinate system chosen to represent the physical phenomenon. This principle is crucial in ensuring that the laws of physics hold true in all reference frames and under different reference frames. So if anyone's ever wondered, how has anyone ever verified what it would be like from this perspective in this reference frame? Well, they do it mathematically by facilitating the covariance, but we're going to see a huge violation here that when you ignore it, it invalidates the whole process. So just because they continue to act like this isn't a thing, you'll start to see the issue here moving forward.
And
So
let me just profess, just as we're going forward, to make sure everyone knows the words being used. Obviously, the claim is that light is invariant, meaning it doesn't vary, it doesn't change. So the speed of light, according to relativity, is constant in all reference frames. No matter what reference frame you're in, the speed of light should always be the same.
Yep, absolutely. And if it were shown to not be the same in one reference frame, then that reference frame would also be the preferred reference frame because it would be the one that you're accurately measuring the relative velocity, of the speed of light, or the rate of propagation, and it would also prove that the speed of light varies. So when you impose an invariant C on all the other reference frames, like they're invalidated. So it's just a mathematical role play that when you don't play by the rules, you can have as much fun as you want. You know what I'm saying? That makes sense?
Yep, exactly. So I just want to make sure everyone gets the basis, because I think some people may not understand exactly how important this is. Like you just said, there's two primary postulates. It's that C is constant in all reference frames. Thus, there is no preferred reference frame. So just like he said, well, if there was a variation of C, that would mean there is a preferred reference frame. So this is a double whammy for relativity if those two things are not true. Okay, sorry to interrupt. Go ahead.
No, you're good. Thank you for the clarification. That's the crux of the issue so far. It's a great recap. So another slide I borrowed from Jody here. So if we just cross out Galilean transformations and use Lorentz here, and then just add C to what should be an invariant quantity. So we have laws of physics over here. These are invariant quantities under transformation. So they should be the same. They should be unchanging. Examples of non-invariant quantities would be, the x-axis, the v-axis, or some variable for velocity, that sort of thing. Those things could change, right? But this is unchanging, right? So moving forward, we'll get into a paper by Ruyong Wang, who works with interferometry and GPS, and he noticed a really huge violation here in the framework here. So the mathematical structure violation, the C in the ECI reference frame is shown not to be the same when transferred to another coordinate system, when the distance derived according to how GPS works should be invariant under transformation according to Lorentz covariance. And then going all the way back to Michelson-Morley, this non-invariance issue invalidates the justification to assume that C has a fixed value and then transform into a new reference frame to ad hoc explain the variance shown as Michelson-Morley as proof that C is invariant, just by using another reference frame. It's a complete insane reification to do it based off of that, but then accept Michelson-Gale and the Sagnac experiment. But we'll come back to that. So anyway, we'll stick with Wang here. So what he shows us here is that how GPS works is it's done off of what's called a range measurement equation and a with the ECI reference frame. So it's a time interval system. So basically what we have here is it takes a snapshot of the coordinates at transmission time and the snapshot of the coordinates at reception time, and then it subtracts it gets the difference of that, and then it multiplies that by C, and then from that it accurately deduces the distance instantaneously down to the millimeter with just that. So what that means is in the ECI frame, the significance of the ECI frame is that it's a stationary, non-rotating frame. The way that they look at it on the globe is you could either be at the North Pole or at the center of the Earth, where you're not experiencing any rotation or orbital velocity. And there's relative motion on the surface of the Earth to you from your perspective or whatever. So the other interpretation of that, because this is literally just a coordinate system right here, the other interpretation would be stationary, non-rotating Earth, and then at the center of it is a ether vortex emanating out. And so the relative motion would be with respect to ether wind instead of with respect to Earth rotation. And we'll find moving forward, I can make a pretty good case for that. So the key points here is GPS is a time interval system, and that differs from how distance is traditionally derived. And I'll get into the differences in the next coming slides. But 3 key points here that Wang also wants us to know is that the Sagnac effect is extensively calculated for in GPS, and not only that, all electromagnetic wave propagation, but and that the preferred coordinate system, the correct coordinate system to use with the range measurement equation to derive the accurate distance using the speed of light, using a law of physics, is the ECI frame. And then he goes on to say most GPS receivers are moving relative to the ECI frame. And so without that, it would be, or without accounting for that relative motion accurately through the time interval system, it wouldn't be accurate. And then he goes on to make the comparison about how distance is traditionally derived. So you would have a coordinate system set up, you would have 2 locations in the coordinate system, and you would just be counting in whatever units of measurement your coordinate system is in, the distance between, the units of length between those 2 locations. So it's not the same thing. And as I continue, we'll start to see why. So the very
on that, let me help everyone out.
Go ahead.
ECI is an inertial non-rotating reference frame, and ECF is a non-inertial accelerative frame that rotates with respect to the stars. So they're different reference frames. According to relativity, should be the same. There is no preferred reference frame, and there should be a constant c or invariant speed of light in both.
Yes, sir. And then so further, so because GPS satellites, so-called, are synced with GPS time, they have their own timestamp situation going on, and they already account for the Sagnac effect in there, which I'll get into later. But yeah, so the reason that the distance should be in an invariant transformation here is because if C were truly invariant in all frames, the distance derived using this equation should transform to the new coordinate system, the ECF frame, which is the one that they say we live on, the GS84 oblate spheroid, ellipsoid, or whatever. So the distance derived though from the speed of light should be an invariant transformation, and it's shown to not be, even though it's synced to the same exact time, and and under transformations it should be the same. The 2 C's from the 2 coordinate systems should be the same. But what's going to happen here is when you transfer the distance derived to the new coordinate system, it's shown to be invariant. That's a huge problem. So the variance of C, so we're calling GPS as a time interval system that derives the distance by using an assumed fixed value for C and the time difference between the signal transmission and the reception time multiplied by C. In its respective coordinate system, the ECI, it is shown to have a preferred direction of propagation east to west, or west to east on the globe. They accounted to rotating into or falling away from the signal. So, which will show isn't even the cause of the effect, right? Or isn't even the cause of isn't even the cause of the effect, because this effect was linearized. So, see, which is causing the varying speed. Let's see. So we'll just read from this real quick to catch everyone up on the equation. Actually, let me show you the equation first. So can you guys?
How fast are their sensors? Like how many tenths of how many points past 0 do the sensor reading go? I know light's moving real fast. I was just wondering how.
So in an experiment done by a guy named Alan and others, it's the Around the World something. I can't remember the title of it, but it's by this guy. It's referenced a lot in these papers. What this guy found was that Paul Marmot. What this guy found was that in an around the world GPS time, it takes 14 microseconds longer going east to west than it does the opposite direction. So there's a preferred direction. It's faster by 14 microseconds and slower by 14 microseconds in the opposite direction.
Okay. Wow.
Is the most precise measurement they've got for it.
That's of course like 1/1,000,000th of a second. So we're talking about mind-blowing the small difference, but in terms of the speed of light and accurately determining location and distance, it's crucially important.
Yeah, because like it says, or like it says in Wang's paper, he references that measuring the measuring accuracy of GPS down to the millimeter is equivalent to measuring time down to the nanosecond when you use the range measurement equation with the ECI reference frame. So that's how accurate all this stuff is synced up. So that distance derived from that should be an invariant transformation. So the range measurement equation here, I don't know if you guys can see it. It's kind of small. It might be, but anyway, it's just the signal or time of reception, time of signal received or received and sent. And that's how they're deriving the distance, the time it takes for that. And then they apply that on the coordinate system. And they're like, oh my God, look, we instantly deduce where you're at. And then when they transform it to where we allegedly live, all of a sudden they have to make all these different corrections to it. So let me back up here. I kind of went over that already. Atomic clocks. So atomic clocks real quick. Some people will say that there's a time difference and that the timestamps, blah, 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 are out of sync, time dilation, etc. So how atomic clocks actually work invalidates that. So do atomic clocks account for relativistic effects? What is a relativistic effect? A relativistic effect is identical to electromagnetic retardation. So basically a wavelength shortening or an oscillation frequency, dying down faster or speeding up if it's moving with or against a magnetic field or any field. So anyway, they calibrate the specific rate of oscillation of cesium atoms by using microwaves in a magnetic field, and cesium's known decay rate or whatever, they keep it in balance with the magnetic field and adding energy to it with the microwave, so they keep its oscillation rate going, and they use that to precisely measure time. So they're on a time system on that. It has nothing to do with adding more corrections or anything like that. It's already accounted for in the timestamp system. This is why the distance derived should be invariant. It all is coming from the same thing under what is being said to be an invariant speed. So that invalidates that, or takes care of that. Yes, already covered that. So I'll end on this real quick before we move forward. So this may seem unexpected, but this is quite an understandable result when we compare the range measurement equation in the ECI coordinate system with sonar systems. Recall that in underwater navigation, sonar uses the same range measurement equation and in a reference frame based on a water to calculate the distance traveled by sound through the sound receiver moving through or relative to the water. The difference here is that the speed of sound in water, A, is used instead of the speed of light in a vacuum, C. However, no one would emphasize the constancy of the speed of sound, and contrarily, everyone thinks that the speed of sound is dependent on the motion of the receiver. So literally same exact equation, that they use for sonar and all that, works exactly the same, accurately deduces the distance based on, the variance relative to the recipient, and everyone's like, yeah, totally. But then when you apply it with satellites, everyone's like, no, C is invariant. It's this, time dilation. So it's just really inconsistent there is what Wang's pointing out. Got that. The traditional distance. Let's see. Okay, so a visual representation of what these equations and stuff mean. So traditional distance, real quick, just to recap, you have a coordinate system here. Ignore the chess pieces. Just look at the coordinate system. So say you want to know the distance between this tile and this tile. Well, you got your coordinate system, so you count your units of measurements. So you go 1, 2, 3, or 1, 2, 3, 4. So this, it's 4 units of measurement away, right? So same thing. So with GPS, what they're doing with the time interval system, they take a snapshot of when the signal was sent here, how long it takes for C to get here. Oh, you got C here. Cool. It took this long. times that by c, we'll get the difference, and then that gives us the distance of, you know, how many tiles down to the millimeter, right? All right. So let's see here. So now we're all caught up on how GPS works, coordinate systems work, and the situation with the transformations and the invariant, and what should be an invariant transformation. So the Sagnac effect here. So we're gonna quickly learn about the Sagnac effect. So if you have an interferometer with 3 mirrors on it, and you send in the light beam, hits the interferometer, you rotate the interferometer, it produces a fringe shift pattern. There should be no fringe shift pattern, but they say that due to what is it called? They basically equate the angular rotation to essentially being a gravitational effect, producing like little micro segments of time dilation that produce the Sagnac effect. This is the one explanation that was given in 1918, I think, from Paul Levine, who made a special metric just to derive the so that he could correctly account for the angular momentum, because and that's another problem with relativity thing, these metrics that these people derive. But we'll save that one for another talk, and we'll just pretend that this metric, you know, accurately accounts for it. This is the story that they say, that due to the spinning of the device, it's producing this, that the Sagnac effect is actually due to angular rotation, is basically what they're saying. Sorry, go ahead.
Because I just want to make sure I make it digestible for
Mhm.
everyone. Just so everyone doesn't know, a quick recap if you don't know, the Sagnac effect was discovered by Sagnac, and he said, "Oh, this is the vortex in the ether, right? And it's basically a preferred direction based on the quote unquote propagation of light, and it's using interferometry." Whenever we utilize this in the Michelson-Gale-Pearson, we were able to match the sidereal rotation, spin the rotation in the sky up to 98% accuracy every single time, and verified that there is in fact a sidereal rotation in a relationship with the light on the Earth and that rotation. That's the Sagnac effect. It's very important. It's used for all kinds of technology to this day. For those not fully grasping the importance of this, this is showing real, tangible, physical, and empirical evidence of the Sagnac effect being accurate, because it's utilized for an immense amount of technology every day. There's really no way of getting out of this. This is a real effect. There's a real rotation that can be detected with this effect. And most of you guys probably know about, of course, Michelson-Morley, and then turning into Michelson-Gale-Pearson. So that's what we're talking about right now, is the Sagnac effect, which is extremely important into understanding this realm, as there is something that's actually rotating for sure. And we see it in the sky, and there's actually technology that can directly detect that.
Yeah, no, absolutely. Thanks for recapping that. And we're definitely going to touch on the history of interferometry at the end if there's time to cover all the bases, because everything is really based off of this, and they just kind of what's it called, hidden the Michelson-Morley thing in the Dayton Miller stuff, and that's crucial to what they're measuring here, because they've never ever once measured Earth's orbital velocity, and that would be a key component to even the accuracy of GPS that we're going to find out here. So that they don't account for, and they absolutely would have to. So yeah, that was a great recap of the Sagnac effect. And so yeah, what Wang points out here is that the Sagnac effect can be fully interpreted through the range measurement equation in GPS. So as I was saying earlier, with your boy Paul Levine coming in hot with a new metric that he derived just specifically to account for this, it's already accounted for outside of relativistic effects. Now, with the range measurement equation, it's not explicitly shown that it's not a rotational effect, but Wang does linearize it, which we'll get to later, and that's an absolute body bag to it as well. So the Sagnac effect derived from the range measurement equation, a non-relativistic effect. So basically what he's doing here is he's saying, he lays out the layout for a circular Sagnac device. So you have a fiber optic loop, or what's it called? Mirror reflectors here, like one here, one here, one here. So what would happen here is if you have a side light here, a side light here, and a side light here, and the Earth's here, you could basically set up a Sagnac interferometer with satellites. And what do you know, when they do that, that's how they got these accurate measurements of the 14 microseconds and all that being the varying speed. So the propagation, definitely shows a preferred direction, and he derives this using satellites and the range measurement equation. without accounting for any relativistic effects at all. So again, if you derived the distance from that and then transformed it, that distance should be invariant as well. And to have a quick recap on the significance of what Wang, or what I'm going to point out here with what Wang does, we're going to watch a quick video. Shout out to Brian Leakey, who clipped this from a presentation by Ron Hatch, who's actually talking about Wang's work here. Let me know if you guys can hear this okay. Play it out.
Okay. Do not hear it, but you'll probably have to reshare with sound.
Oh, I see.
Yeah, it'll be a share computer sound at the bottom.
Okay. Let's see. So stop sharing and then reshare?
Yeah, and then there'll be a share computer sound.
Gotcha. Oh, share with computer sound, my man. Okay, cool. All right, here we go. Let me know when you're up.
Good.
All right.
A little more.
Audio good?
Okay.
Yes.
All right, cool. Play it out.
A little more one-way Sagnac effect on the Earth. The measurement is the result of Earth's rotation around the Earth. I claim that that's absolutely false. Wang has done some experiments with conveyor belts and shown that their circular equation right there is really equivalent to the length and can
So the circular equation here I'll show on the next slide so it's bigger so everyone could see it, but this is the equation that they use to typically derive the Sagnac effect and how much fringe should be produced. This is a equation that Wang made, to describe the same thing with a linear effect. And what he found is actually that these equations are actually interchangeable, and that the effect isn't due to rotation at all. It's due to relative direction and the other thing. Can't remember. I'll play it out though, and Ron will cover it.
put in terms of the length. Well, on one-way path, you'd expect it to be half as big. The GPS experts claim, there's this triangle that it follows, and they put it in the same form for a one-way because of Earth's rotation. But again, if you work it out, it turns out it's just VL over C squared. And when you put it in terms of where the satellite and receiver are, it works out to be exactly the same as that VX distance along the equator. And so there's clock biases that have to be accounted for in GPS to remove the Sagnac effect. Everybody asks why there isn't one for orbits. Well, there isn't one for orbits because they're all affected by the same amount. You just adjust your clocks. The clocks have been adjusted and are automatically kept that way from the argument we've.
So what I was talking about earlier with the clocks already accounting for the Sagnac effect in them, that's what they're doing. The clocks already keep the relative time so that they're all in sync together, maintaining what's called GPS time.
Already given. A little bit more proof of that is GPS has to include all receiver motion in the effect, rotational, and not just not whether it's just rotational or not.
So that's an important distinction here that we'll come back to, because what we're going to find is that the amount of time it takes for the delay is proportional to the velocity of the person in motion, or of the receiver, or the whatever's in motion. So there's a relationship involved in that, and because it's not a linear effect, it's obvious. It's obviously not due to Earth rotation.
And that's the ICD document that claims that that's the case. So again, it's not a rotation.
In the ICD document, these are the documents for like the satellite manuals and all that stuff. So this is them saying that like Earth rotation or not, blah, 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 because they know that it's proportional to the velocity of the receiver, which, explicitly isn't supposed to be a factor that matters in special relativity. If we recall back to the first postulates.
It's a fact that the receiver and source are moving. Which incidentally, I came across a paper a long time ago, I haven't checked on it recently, when they tried to compute precise orbits with radar of the planets. They did not get the right values, and they tried it with and without Einstein's theories, and it didn't work either way very well. I claim that they're not taking into account this flattening effect and the speed of light changes as a function of direction here. The length contraction is different in different directions. And
the length contraction is different in different directions, boys. So there's or the preferred, or it's going with or against an ether wind, right?
Incidentally, that'll cause a very tiny change in your
Oops, sorry about that. I reset the whole thing. But anyway, that was the end of that. So we'll move on to the next slide so I can show you the equation so you guys could all see what was missing on the slide there. So the circular equation right here is just describing the rotation of the device, the area of the device, for the rotating Sagnac device. And then the linear equation was just the length of, basically the length of the cord he was using. And he derived the same exact effect and showed that it is not a rotational effect. So this special metric that Paul Levine came up with to account for the angular momentum, so that he could say that it's creating little micro time dilation instances in every part of the turn or whatever for the rotations. Blah blah blah. Cool story. It's not relevant. It's shown to be outside of that, right? So. The Sagnac effect is a non-relativistic effect. The Sagnac effect is directionally dependent. The Sagnac effect is not due to angular rotation. The confines which general relativity attempts to co-opt the Sagnac effect is invalidated without GR's angular rotation solution, provided there is no mechanism to explain the effect within relativistic means for general relativity, specifically with that metric. I should clarify on that, because they could still have a shot with special relativity if they pretend or whatever, but the angular rotation was in specifics to general relativity, just to be clear. Wang demonstrates that in an inertial frame, there's a varying speed of light, and that this violates special relativity's postulates, rendering the framework untenable and unable to answer it without ignoring the fact that C objectively varies in the preferred reference frame. So, like I was saying earlier, as long as you just don't acknowledge that C is actually variant, you can kind of pretend with special relativity and fit it in there as well with a couple different ways. But yeah, overall it's a body bag. Just anyway.
This is why they had to. I'm sorry to interrupt, but this is why they had to define the speed of light as constant and just leave it at that.
Yeah, exactly. They can't have it go back on, because the whole system collapses off of the back of this. So this is why they don't talk about it. They just, in the GPS manual, they're like, hey, account for velocity, even rotation or not. You just do it and don't ask questions. We'll take care of it on the other end. It's like, okay, boss.
So shouldn't it change depending on what latitude you were on? Do they take that into account in their calculations?
The range measurement equation automatically does it. It automatically accounts for the varying speed based on the time interval.
Wow.
If people fully understand, this is such a death blow to the current paradigm of scientism. The fact that they claim length contraction is different in different directions. There's a different amount of length contraction, which they can't. That's why they can't even tell you what supposedly causes it. It changes differently in different directions, and there's a different value for the speed of light in different directions. This completely refutes the entire idea that the Earth is a spinning globe revolving around the sun.
Now, do they take all their measurements near sea level, or do they take them at high altitude as well?
What do you mean?
Of the things that are length contracted?
Yeah.
No, So the Michelson-Morley stuff that they length contract was done in a basement, and there's that. They length contract in a basement.
Yeah, to clarify, they're not ever actually measuring length contraction.
Yeah.
They're just, we assume that the speed of light is constant, but we see that the distances are different, or the times are different. They're going to have to claim that length itself contracted, the distance contracted relative to that speed of light, and it contracted at different rates in different directions, which only makes sense if there's some variable that's creating that preferred direction.
That is so funny.
So all of this just to keep the Earth in motion.
Yep.
Not acknowledge the
Oh, dude, it gets even worse, bro. But yeah, all to keep the motion concealed, man. Like, they're hiding a very big lie on this.
Length contraction. They're actually saying that the physical Earth is contracting one way.
The apparatus.
The apparatus, or the wavelength of light, or whatever,
Actual distance that this light's supposedly traveling is getting shorter, and it's getting shorter at
crazy.
Didn't they also eventually shorten one of the arms Is that the later experiment? Dayton
Well, that
Miller?
was Morley. That's where they actually got the length contraction in the. After that, to test the length contraction postulation from Lorentz, they actually shortened one of the arms, and then it didn't work.
It
So
didn't
that
work.
threw out the ether contraction theory, and then they said, "Oh, it's just a relativistic contraction, and you'll never be able to detect
Yeah,
it."
You'll
And
never.
now this just dunks all over that by showing, oh well, if you believe there's something there that you can't measure or detect or observe, now you're saying it's doing it at different rates just based on which direction it's going. That makes perfect sense with an ether wind, right? Because it's physically going in one direction, but it doesn't make any sense with relativity. Makes no sense whatsoever. Should be all reference frames should be the same. There should be no preference, and then the speed of light should be constant in all directions. Bad. This is bad for.
Yep. All right. So,
now,
oh, go ahead.
especially now that we officially have the maths, right? So really absorb this, and then when everybody's like, "Well, how would it work in the flat Earth?" Why don't you just show them this presentation?
Exactly. All right. So this means the Michelson-Morley experiment was not a null result or due to experimental error. The velocity scale, which was applied to the fringe pattern, was off. Michelson-Gale and Sagnac are essentially the same exact experiment as Michelson-Morley. If Michelson-Gale and Sagnac detect a fringe shift corresponding to a sidereal rotation, then Michelson-Morley must also be the same valid detection. The only difference here is the scale invoked to interpret the results of the orbital velocity. Therefore, it is completely unjustified to Lorentz transform to a reference frame of an observer on the sun to theoretically explain length contraction that would have already happened in our reference frame to derive the correction needed to infer Earth's alleged orbital velocity from the 5 kilometers, and then unlength contracting it out to 30 kilometers, and then to turn around and use the same fringe shift reading as an angular rotation reading of 15 degrees per hour corresponding to a translational speed relative to the latitude. It's like that's insane, you know. So that makes sense. That kind of actually just recaps what you said, basically.
Yeah, it's wild that they've just swept this under the rug. GPS is the number one thing people love to bring up for the globe, and it actually destroys the notion that the Earth is a spinning globe.
How to debunk your own position in 5 minutes or less.
Yeah, for real, dude.
This is why this presentation is so important. I wanted to get Alan on ASAP because it rips GPS away from them. Actually, it refutes their position with GPS.
Yep. So I'll read here from relative simultaneity, and it's pretty straightforward here, nothing too fancy. So relative simultaneity versus what they call global simultaneity, but we can go ahead and call it planar simultaneity. We'll just rebrand it, no big deal. Let's see. In any debate about the speed of light, the problem of simultaneity is always a focus. Special relativity claims relativity of simultaneity, which states that two events occurring at two different places which are viewed as simultaneous for an observer in a system usually will not be simultaneous if viewed from an observer in another system. But contrary to this, simultaneity is key to GPS operations. GPS is a timing ranging system. It does not directly measure the distance between two places where two events, i.e. the signal transmitting and receiving, occur. It measures the difference between the instant when these two events happen and the distance is calculated using the range measurement equation. GPS especially, its space segments and control segments make huge efforts to establish and maintain GPS time. So this is what we were talking about earlier with the atomic clocks and all that stuff. So in the scope where GPS is applied, roughly a scope of a diameter of 50,000 kilometers or bigger, if one is using GPS, one is using GPS time, and therefore the concept of simultaneity, Therefore, said it backwards. If one is using GPS, one is using GPS time, and therefore the concept of simultaneity of GPS, right? So they call it global simultaneity or whatever. Two events happen at two different places, and then he gives the coordinate system for one event, coordinate system for another event, and he says that these two events are simultaneous if the time that they took place in is equal to the time that the other event took place in for the other coordinate system. And this is true no matter who the observer is, where the receiver is, or what the status is, or what speed it is. This is the basic operational principle of GPS. We call it global simultaneity. In the books about special relativity, the most commonly cited example of about relativity of simultaneity is the example of the railway platform and the moving train. It says that two events, e.g., two strokes of lightning, A and B, which are simultaneous with a reference frame to a platform, are not simultaneous with respect to a moving train and vice versa. But now GPS receivers have been extensively utilized on railway platforms and moving trains and lightning at two different places, A and B, conceptually at the same time as emissions from GPS signals from satellites or DGPS stations. So while all this is happening, everyone's getting their signals. Signals are being emitted and received all in the same event. So like all in the same timestamp, and it's all happening. This is all happening relative to one another, and it's all in sync somehow. Beyond the scope of what relative simultaneity describes. So the accuracy of GPS, because it's derived based on the time and the time difference of the speed of light, from when the events occur, transmission and reception. If it wasn't all truly in sync, then it wouldn't be accurate. It wouldn't be right. Everything would be off. The timing would get messed up. But somehow, miraculously, it all works. And the Steelman position of this is, well, this is just a local effect. Just trust us. It only happens in this reference frame. All other reference frames, it doesn't apply. Just ignore this and go back to sleep. Michelson-Gale-Pearson. So this is in regards to the math that we were talking about earlier and what Zach brought up about, the speed changing relative to the latitude. So Michelson-Gale-Pearson, they did, what was it, at the 40-something latitude, 1923. He mentions here in his paper that the math that they're using is based off of a fixed ether model. So basically, they're using an ECI reference frame to measure the relative velocity of the speed of light as it travels from the, where's my mouse at? As it travels between the length of the pipes going north-south and the pipes going east-west. And what they find is that, the pipes going east-west have the varying speed, and that's what's producing the fringe, and that speed difference corresponds to the latitude. So they, derive it that way with no relativistic effects or anything like that. And he even says here in the paper, for some reason, that, this was derived with the assumption of a stationary ether as well as in accordance with relativity. Not sure how it's in accordance with relativity. A preferred direction of light that varies due to the latitude is, it's not what I would call a prediction of relativity if the postulates are that the speed of light is invariant in all reference frames. So let's see here. The speed of light relative to what? Sorry, go ahead.
Oh, no, I was just going to say, if you claim that it's in a line with relativity, then maybe it'll get published.
Right. So, let's see here. So yeah, so in the measurement here in the math, they're saying the speed of light is being measured relative to something, but relative to what? Relative to Earth rotation or relative to an ether vortex, right? And as we deduced earlier, because this is a linear defect that's dependent on direction and not rotation, it's it's pretty obvious what the answer is here. So the varying speed of light, what it's being measured relative to. The varying speed of light is shown here in the Michelson-Gale to mathematically derive the results, measure the difference of C north-south through the east-west pipes relative to one another, respectively. The implication here is that a preferred frame is used to measure against the velocity that produces the accurate measurement of the variance of the speed of light. And there's only one of these frames that produces such a accurate measurement, and it's when you do it against an absolute reference frame to measure the relative velocity. All right, so what is responsible for C's variance? Orbital velocity or Earth's rotation. So another complete failure for the heliocentric model is that Earth's orbital velocity isn't added to compensate for the linear motion experienced when Earth is rotating in its orbit around the sun. If the claim is that the linear motion of Earth's rotation is what's being accounted for, then Earth's orbital motion must also be accounted for. So here we have two papers talking about this effect, and we'll go over those in a second. We'll look at the graphic here. So we have, the orbit of the Earth around the sun, it's doing its thing. It's going this way. And then the Earth rotating. So if it was rotating into it, these are both linear motions. They should both be the same. So if they So an observer here, standing on the surface of the Earth, rotating into this orbital velocity would technically be experiencing that motion. So if that was truly the cause of the varying speed of light, GPS would have to calculate that. And in this paper from Ching-Chong Su, they proposed that maybe there's a local ether effect, within the Earth's atmosphere and all that, and that the Earth is rotating through that stationary ether, obviously, right? And the Earth is rotating through that, and that's causing the discrepancy. And then he notes here that perhaps this local ether effect isolates us from having to account for Earth's orbital velocity. And he mentions here that if GPS were to account for the linear speed of Earth's orbital velocity, which is 100 times that greater than of Earth's rotation, GPS would be inaccurate, and they explicitly don't account for it. So it's an unnecessary correction that they don't really talk about. So,
How did they get away with that? I mean, 30 kilometers a second is fast, and you would think they would have to account for that for sure.
Yeah, and they explicitly don't.
It gets even worse than that, because since then I have a presentation from I think a Stanford professor who explains that there's still debate going on about Michelson-Morley and how they don't account for the orbital velocity, because in fact they believe they should have also had to account for the sun moving also. So the sun moving through space would also be variable.
I've seen the work on that where after transformations, they so in the first transformation system, right, they derived that these fringes would correspond to 5 kilometers a second. Now, after transformations to where they're going to calculate for the orbital velocity of the sun in tandem with this to try and bring it in alignment, after the transformation, the distance the velocity that they get is like, 230 kilometers a second. So it's pretty close to what they say the sun is. Like, they literally try and co-opt the Michelson-Morley experiment by just transforming to an insane speed that they still no one's ever felt. But it's just a literal mathematic, like, ad hoc thing. Like, yeah, they're trying to do it. I don't think they'll be able to do it because, like, then they would have to also account for it in GPS, like, if they're going to try and do that.
Yep. Yeah, it's best to just ignore it. Just ignore it and make sure that the average person just says GPS proves relativity, and they'll never know.
Yeah, exactly. And that's how they're getting away with it, because people don't know this. They're unaware of it. And we've all been told, like, surface level narratives of GPS and how they account for relativistic effects and stuff. And then it turns out one of the only relativistic effect really that matters in this situation is the Sagnac effect. And it's explicitly shown to not be a relativistic effect. So, it's been real.
If they have
maybe a good point to say actually that there's no agreement on the relativistic explanation for the Sagnac effect. By the way, like there's like over 10 alleged explanations. It's still debated, and none of them work. Like, so they don't even know how to try to make this make sense in the top levels of academia in 2023. And this effect is not new, of course.
Yeah, absolutely, man. And like Paul Levine coming through with his own metric, which is a first order a first order intrinsic invariant differential, which means that's a mathematical violation in and of itself. But, like, just trying to fit that in the confines so that they can account for the angular momentum, it's just such a role play. They've never been able to explain this ever. It's a complete contradiction to the paradigm that they were putting forward, and they had to co-opt it. And, like, yeah, what it was saying, I've seen so many different explanations to it. I kind of forgot them all, and they, like, blend together because they're just like, it's almost as if it doesn't matter what they say as long as they're just trying to portray something that sounds like a relativistic effect. Everyone's like, oh, thank God he's one of us. Like, he's not questioning it. He's not pushing back. So yeah, it's pretty preposterous, or pretty crazy to see it being explained various, having so many different explanations. Like, if it was truly so cut and dry, like, it would just have a simple explanation, and it does not.
Exactly.
Yep. So let's see here. So GPS specifically doesn't account for the presupposed orbital velocity, and it should. And I think we can move forward on this one. So let's see. So the moving and stationary receiver. So this is where we get into the distance derived is proportional to the velocity of the receiver, right? Or the time difference in the speed of light or whatever, right? Is derived from that. So if you have a stationary receiver and a moving receiver here represented by R1 is your stationary, R2 is your moving. So when these two when R2 is about to pass R1 and they're at the same exact point in time and a GPS signal is sent, R1 receives the signal first, even though the time that they get it is the same and the distance should be the same and all that. He gets it second, and the delay in that is proportional to what's it called? His velocity. So when you're at rest, there's no additional boost that you're getting other than the relative, what it would be relative to the latitude, based on the ether wind, and then the relative motion of, another receiver is the determining factor of who gets the information first. So when you're stationary and when you're at rest, you're truly at rest with respect to, the rotating universe, essentially, right? Everything's rotating above us, relative to us. So I think that was my extrapolation out of this situation here.
Yeah, I've heard that before. It was actually a scientist down in Antarctica talking about GPS, saying that you can't stand still when you're trying to get your GPS coordinates. You have to be on the move and moving, or else it won't give you accurate GPS.
Oh, that's not true.
Okay.
It gives it accurate either way. What I was saying is that the time difference, there's a time difference in the signal, even though the distance is the same.
Okay.
So,
well, why would he say that then? Why do you think he would say that?
I have no
He
idea.
said down there in Antarctica that that he had to be on the move to get an accurate reading.
I have no idea.
It was weird.
Doesn't make any sense.
Well, I will say this. This is an interesting point to point this all out so everyone can understand this. So what we're saying is that when you're at rest on the Earth, you're actually at rest.
Right.
And there's like an ether wind, and it's basically the cosmos moving around you, which we all observe all the time. And then when they claim that there's motion relative to the center of a ball that's spinning, actually it's relative to the center of ether vortex, and that's where you get the latitude correlation. Having a different sidereal rotation that you detect with the Sagnac effect makes perfect sense that it would be different at different latitudes because you're different distances and angles away from the center of the ether vortex. So when you were to say hypothetically get all the way out towards where we can't go, I don't know that any of us would truly know what you'll read there because we can't go there. I mean, even just getting past the equator is kind of suspect, much less past 60 south latitude. But I hope everyone gets that point, which is there's basically the cosmos moves around us. All right, so that's a real angular momentum, a real rotation that happens. When you're on the Earth, you're actually at rest when you're not moving. But the cosmos isn't at rest. And so that's why you would have a different distance and angle away from the center of that vortex that's moving around the Earth, like encapsulating the Earth. And then you would have a preferred direction, east to west, because that's the direction the cosmos moves. That's why the propagation is more effective or efficient in that direction, all relative to a stationary Earth. Hopefully that makes sense.
Yeah, absolutely, man. Well said. Well said. All right, so we can see here. No Earth's orbital velocity corrections needed for the propagation speed, and the Earth's rotation is a linear speed. The velocity would have to be accounted for. Blah, blah, blah. Yeah, and it's not. All right, so we can move on from that. So the TLDR, the linearized Sagnac effect, i.e. the linearized Sagnac effect, i.e. non-rotational effect, falsifies special relativity on the grounds that the postulates regarding the reference frames and the constancy of the speed of light are not true in nature. Lorentz covariance is violated under transformations of distance derived for the ECI using C is shown to be a non-invariant transformation violating the mathematical structure upon which the theory is built. The principle of relative simultaneity is also violated by GPS because the time interval system in which multiple simultaneous events happen relative to one another, regardless of their motion, happens every day, all day. GPS's accuracy depends on special relativity not being true. And here we're going to look at what Whitsitt was just kind of saying there. I got a couple graphics I can show of the ether wind or situation. Yep.
Take that picture in. That's
Yeah. So
early.
So right here, your boy ether vortex emanating out, it would be, overarching over here. So as you get further away from it, you're going to have a loss of the translation of motion. And at the equator, what could happen is if it's following like that magnetic field toroidal donut situation, right? So the inner hyperbola is going to have this speed and the outer vortex is going to have its own speed matching. So it would still be symmetrical. The key variance here is that the how you would have to tilt the device to maintain the accurate readings. So the device has to be axially or parallel or aligned parallel to the axis of rotation. So basically, around here, they're making 45-degree axial tilts to the device to measure the motion. Same on a globe, same on a plane. But the only thing difference here is that the effect has been shown to not actually be due to rotation, right? It's not an angular rotation effect. It's a linear effect due to the direction, right? So don't be intimidated by, thanks Bob or anything like that. This is hands down irrefutable evidence of like what it was just saying of an ether wind with respect to a stationary non-rotating Earth. Otherwise, they would have to explicitly account for other velocities, and then now they're even trying to add even more velocities that they're still not actually accounting for in any of the technology they use. So GPS and all interferometry is explicitly planar ether technology. And, make of that what you will. You can look into it for yourself. Let me show the last slide here. This one, yep. Sorry, this was a video.
Oh, we lost your screen share, I think.
Oh, 1 second.
Yeah, we should stop saying that it's the same as the globe, same as a plane, because obviously we're finding that it's not working on the globe at all, and that it seems to only work on the flat Earth cosmology.
Yeah. Is the presentation back up?
Yeah, and I know one thing, dude. Bob would absolutely love that we're popping this up because he was screaming this for 2 straight years. He's like, we have technology that proves that the Earth's not moving and that we have to utilize the ether wind. It's proven every day with tons of technology, and it's actually impressive that it was swept under the rug. So it is certainly time that we take it back.
Yeah, man. So everyone in all the comment section, when you see someone thanking Bob, like you just know they have absolutely no idea about anything, and they're very comfortable, not knowing about this stuff, and it's not surprising that that it's like still is continued on this day or whatever, because it conceals such a heavy thing, right? Like this is such a big deception and complete failure for relativity, and the ether's unnecessary, and it could be a globe. Nah, man, it really can't though. And this is direct evidence of that. And yeah, I mean, like moving forward, I think we should start incorporating these arguments and like changing the game up a little bit. I mean, the meta should be taking science back, what they've taken from us and lied about and used it to invert it to tell us that we live on something that they can't even measure. That with all their given science, they can't seem to measure the motion of the most important, crucial part of their model for us to believe it. So
This was always a matter of time before it started going this way, and that's why the trolls try so hard to waste time with all these bad arguments that just keep people spinning the wheels if you're not smart enough to see through it.
Yep. But yeah, so thanks for your time. It was an honor to present here and bring this. Appreciate that. If anyone has any questions or anything, or we can open it up or move on to whatever you guys want to do, or would you like to piggyback off of this and do the history of interferometry real quick so we can kind of power through it?
Yeah, it sounds good.
Yeah, I'm certainly open. I'm certainly open to you covering that as well. If everyone else is, we can.
Sure.
I think that if anyone on the panel has any comments or questions as to exactly what we're talking about, or anyone in the chat, so we can just make sure that everyone kind of understands. I think that we covered it decently well by breaking it down. It's pretty simple, right? Like the very technology that they use. I know a lot of people are gonna say, "Oh, what satellites GPS uses position around
Yeah.
blah blah blah." Yeah, but the point is that the actual math applied to the coordinates of people on the Earth has to utilize a flat Earth that's stationary effectively. They have to use a stationary Earth with an ether vortex with a preferred direction to even get the proper distances. And when it's assumed that there is in fact a preferred direction, a difference in the quote unquote speed of light, we'll say, based on that direction, all of the distances work out. Now, of course, they run that through a transformer. They transpose a globe onto the plane Earth. That's a separate thing. The point is that they have to utilize a stationary Earth with motion in the background or the ether coming from the cosmos effectively to accurately utilize any of the technology. So any type of use case that's effective when they call it GPS is direct physical evidence that the Earth doesn't move, that there's a preferred direction based on the ether wind. And this is incredibly damning to their paradigm, which is why it's been just completely hidden. And I was making this point the other day. I think that one of the most effective tactics they use is when something refutes their paradigm, they actually invoke it as evidence so that no one thinks to look there. How they were like, oh, the cosmic microwave background is evidence of the Big Bang. Actually, it debunks Big Bang cosmology. Right. So that's what they did with this.
Yeah, it debunks it, man. And you can even, they're even talking about using the CMB because it's, homogeneous and isotropic, so to speak, well enough for them to use as a background reference to measure relative motion against, dude. So like, they're even like, they're just trying not to admit it while simultaneously doing it mathematically and then pretending that they're not.
Yeah, one more thing I want to say about the satellite idea. Like, I for one don't in any way dispute that there could be things moving around in the sky above us. Because when you actually look at their equations, what they do is they treat it as if the Earth is in the center and that it's stationary and that there's momentum coming from the sky, and it actually utilizes that inertial force, the set of inertial forces being the Euler forces, the centrifugal force, the Coriolis force, all real forces though. It utilizes that inertial set of forces to even like on paper have a supposed satellite, and when you look into it, they seem to follow magnetic flux lines. So it's certainly not impossible that they have some type of technology utilizing this ether wind and going around over top of the Earth. It isn't impossible. And I just want to make sure people get that. I know that a lot of people have said there's no such thing as satellites. We know it. They're all balloons. Well, for one, even if they're using groups of balloons to do this, they're still interpreting it through this same framework or lens or set of equations where they're actually treating it as if the Earth is stationary with ether wind. In addition, even if something's there, that isn't a problem for us. So this is in every way, it checks the boxes as an important aspect for people to familiarize themselves with, take it back from them. And one thing we've found is every time Alan falls off into a Discord and gives his presentation, you just hear doo 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 doo. Your ballers just run from this.
Now, the GPS, is it the same over land as it is over water, in your opinion? Are they using the same technology, or is it mostly tower-based over land and maybe balloons over the water or something like that?
I would have no way of knowing what they use where. It's all facilitated on the time interval system. So on the back end of it, right? So in terms of orbit and all that, and like why these people still think that they're on a globe and stuff, when they have access to the raw data or whatever, and they're looking at it, and the back end of it is through a scale invariant system, they can just have it spoofed in where the orbit diameter and all that stuff looks like it's coming from that distance and everything. And the only real part that would matter would be the snapshot of the coordinate system, for the time propagation, right? Or from transmission to recipient. So on the back end, they could make it look like, this is GPS data from a thing orbiting, X amount of distance, right? But it wouldn't even be that. That wouldn't even necessarily have to be the case. And as long as it was scaled with invariantly on that end, it would be proportional.
One quick to everyone, including you. In 15 minutes, we'll be going over to Rockfin. That's rockfin.com/globebusters. We'll drop the links in the chat over the next 15 minutes. So again, the second half of the show will be exclusively on Rockfin. It will be free while the show is live. And then I believe it may be switched to premium. Just a 15-minute heads up for everyone to migrate over to Rockfin. And if everyone else is on the panel is cool with him covering interferometry, then we can do that. Or if anyone has anything else they want to throw in first.
Just one last time, very simply, I want to make sure that I understood it was, so in short, the mathematics that were used for the supposed time dilation and orbital mechanics for the satellites are in fact actually flat Earth mechanics with flat Earth predictions using a ether spin instead of time dilation, and it actually works. So that would be a direct refutation of relativity, which is the linchpin of physics today that debunks or supposedly debunks why we don't experience any motion. So now we can just admit the observations that we are not moving and that we are the center of the universe. And it's as simple as that.
That's correct. And it's not even, it can't be stated like, oh, well, maybe relativity's wrong. Well, no matter what theory you came along with to try to replace it, it's still going to have to stamp that core tenet, which is that there's no preferred reference frame and that there's a constant speed of light in all reference frames, because that's the only explanation for Michelson-Morley. So you have to say that, even if they come up with some new theory that replaces relativity. In order to explain Michelson-Morley, they're going to have to say that there's a constant speed of light in all direct frames and there's no preferred reference frame. So this right here just objectively refutes the notion that the Earth is tilted, wobbling, spinning, and revolving, no matter what they do, with or without relativity. And yeah, it's a direct refutation of relativity, which was done in response to Michelson-Morley. So exactly, this proves that the Earth does not move. It proves it.
Well said. All right. Are we ready to continue?
Yeah, Jaron, I saw you light up. Were you about to say something?
No, I just said it sounds good to me. I did put in the chat there that the universe is now 26.7 billion years old. They just new study shows, so they can obviously.
Nice.
Nice article. Nice article. They are correcting, and also they correct the age of the moon. 200 million of year more. old.
Oh, when's his birthday? You think probably?
Well, right now 200 million years before.
Oh, nice.
Now, aren't there stories of humans that talk about a time before the moon?
Yes, I've heard of that too. Yeah, Native Americans and the Aborigines in Australia.
The greatest game of telephone ever played.
True.
Saying they just doubled the age of the universe. It was 13.5 billion. Now it's 26 billion.
26.7, yes.
They supposedly found like 75 more galaxies out past where they thought the Big Bang would be. So that probably has something to do with it.
Yeah, exactly. There's galaxies that are too formed where they are, so they're going to have to just add time to it. Wow.
Which works perfectly for their evolution story. Of course, right? They just
Better.
want more time. Give us more time. Oh, no, I guess this doesn't change the Earth, though. At least yet. We'll give them time.
Whatever happens in billions of years can happen in, quadrillions of years.
Very true. Numerous times over and over again.
Who needs God of the gaps when you got time of the gaps? All right, so again, 10 minutes out for Rockton. I think if everyone's good, you can go on with your presentation when you're ready, and I will jump in 10 minutes just to let everyone know that we're switching over.
All right. Okay, so piggybacking off what we learned about interferometry and the Sagnac effect and how that works, we'll go ahead and just cover the history of Michelson-Morley. We already did Michelson-Gale. Like all these interferometry experiments are essentially the same. So once you have the basic concepts, you don't really need to dig too far into it. So I won't have to go through the whole presentation. I'll just kind of skim through some of the stuff, and then we'll get into the Dayton-Miller gravy, which is the real significant, repeatable, accurate measurements of the fluctuation of the ether wind relative to the how the sun moves in the sky above us. So I'll continue off of that. So I don't have this actually laid out correctly, so I'm going to leave it not in full screen mode. I apologize for that, but I need to see where I need to skip ahead for the slides. So this is all your laser interferometry now belongs to us, meaning that we're taking back the experiments that you guys took from us. So anyway, quick recap on interferometry here. So we have various Michelson-Morley type devices. So there's the input for the laser, reflective mirrors, beam splitter, prism, and the idea here is that the light will come in, hit the beam, reflect, and then hit a photographic plate, when it gets recombined, and they'll get a fringe shift pattern. And what they were trying to do is measure or its orbital velocity with this. So what's the difference between heliocentrism and geocentrism? And there's a nice graphic here that's out of proportion because I changed the slide. Second. Oh, it's not going to play. All right. So anyway, these coordinate systems are, what's the difference between them, right? They're just coordinate systems. So how could you measure the distance between them? So they were proposed that using laser interferometry, they could do this. So quick over topographical view of the Michelson-Morley device. You got your laser, beam splitter, photographic recorder, 2 plates, or a photographic plate, and your laser hits the beam splitter, the light reflects back, recombines, hits your plate, then they're looking for the displacement. If the speed of light is the same, then there's going to be no fringe. If the speed of light varies in one of these directions, there's going to be a fringe pattern. And from that, they're going to deduce, the motion from it, right? So let's see here. So when you do interferometry, the fringe shift patterns produced can tell you various things about what you're looking at. So you can use it to measure the refractive index of something. You could measure it to use, motion. Let's see, what was the other stuff you could do? It's all out of proportion on the thing. Anyway, it's a useful science, and how light interacts with the prism produces these fringe shifts. And from that, you can, deduce things about what happened to light on its journey or the nature of what's producing the fringe shift pattern, right? So we have here Airy's failure, starting off where they were going to tilt the telescope, and they figured they had to tilt it by 30 arc seconds to account for Earth's motion relative to a stationary ether. What they found is they didn't have to tilt it at all. So they said that, there must be no stationary ether. Michelson mentions here that if you want to believe in a stationary ether, you must have to believe that there's that the starlight was carried in opposite direction of Earth's assumed motion to drag the light ray through the telescope in such a way that it wouldn't have to require a correction. So the TLDR conclusion here is that a stationary Earth with respect to a ether wind would produce the same effect, for no correction needed. And they just, the way that they frame it again is through the Michelson-Morley paradigm, where they say that it's only with respect to a stationary ether that is the quote unquote failure part, right? So, and then moving on, Michelson-Morley was done in 1887. So earlier when I was talking about the fringe shift patterns and the scaling, right? So this is what they predicted they were going to get. So they have 5 fringes marked off here, and this is what they actually measured, just over one fringe. And if you remember back, one fringe was going to be equal to about 5 kilometers a second. And they didn't measure that at all. So they said, no result, instrumental error, that sort of thing. And then later on, through relativistic means, they invoke a transformation to a reference frame on the sun, where they deduce that the amount of length contraction that we're experiencing in our frame is what's producing the quote unquote no result. So that's how they explain that. And remember, the scale of interpretation here of how they produce the 5 kilometers is according to their math scale of how they scaled up for the interpretation. This isn't an actual speed or anything that they actually measured. And again, when they get down to Michelson-Gale, you're going to see that it's just that quote unquote roughly 1,000 miles per hour at the equator relative to the latitude speed that they're measuring. The fluctuation is. Let's see. So Michelson-Morley length contraction. So Henrik Lorentz came up and said, hey, maybe there's an ether contraction situation going on. So they've just kind of explained it through that. And then Einstein came along and said, hey, maybe the coordinate system itself is contracting. That's where you get apparatus contraction, the length, distance, and all that kind of stuff that's described by the coordinate system contraction. He's attributing this to a physical effect that's producing the null effect, and everyone just kind of went with that. So they said, yeah, we don't need an ether, and then all motion, if you're in uniform motion or whatever, you're not going to be able to tell the difference. So they were through this mechanism, they were able to maintain saying that they were able to remove the ether as a component and then assume Earth's orbital velocity, and then have an explanation as to why they can't measure it and why they're only measuring the local effect of Earth's sidereal rotation.
Science.
Yes, okay.
This is the most ridiculous thing ever. Bob used to always harp on this. This is such this ends everything as well. If you use interferometry and use the same methodology and the same framework of the ether to try to detect the orbital velocity in Michelson-Morley, and you don't detect anything, but then you apply that same methodology of interferometry to the sidereal rotation and it matches perfectly, and you do detect it, the only viable solution is that the Earth is not moving and there's only one real form of rotation, which is the sky. If there's two different forms of motion, then the same method of interferometry would detect both the orbit and the sidereal rotation. You cannot have them both be together with different results, which means the only solution you're left with is a stationary Earth.
Boom, there it is, man. Well said. I came to that realization the other night when I was thinking about this because I was like, how did they get this 5 kilometer? Like, what could that even be? And I remember thinking that maybe it was, maybe there was something out there that they were measuring at that. And then I realized like all these experiments are the exact same, and you can't do that if it's measuring the same thing. It's not going to be the sidereal rotation isn't also going to be 5 kilometers a second. And I realized it was just a scale that they made to interpret that. So yeah, it's exactly right. You can't do that. It's insane. And they do turn around and try and co-opt the Michelson-Morley experiment by invoking that new reference frame in which C is the measuring stick, right? So the measuring stick that's shown to be variant in an ECI reference frame where you can measure relative motion against an absolute frame. That same C, right? So, yeah, it's an absolute body bag to that. So yeah, in the math in Michelson-Gale, which is what Witsit just pointed out here, they use the same framework, just without applying the scale that they were using to interpret the fringe. And what do you know? It matches the sidereal rotation. So Sagnac did in 1913 did his interferometry experiment, and basically it was a rotating Michelson-Morley device, and he found that was where they found the Sagnac effect or whatever, and that was when what was it, 8 years or 10 years later, Paul Levine published that thing for making the Sagnac effect a quote unquote general relativistic prediction and all that stuff. So yeah, for years it this effect went unanswered by relativity on all fronts. And then, for special relativity, they just discounted it because they said that it was a non-inertial reference frame because it's a rotating device. But as Wang showed, and through the math and through experiment, it's directionally dependent, and it's a function of the length of the cord, right? So even in interferometers that are much smaller, I think even Wang says, like, even accounting for it down to like centimeters, it's it's still an effect that has to be accounted for. So there's no getting around it, and it's not a rotational effect, right? So it's directionally dependent. What's that?
Really important.
Going good.
Oh, sorry. I was just going to, again, reiterate that things like this are very important because they demonstrate on their face the logical inconsistency of it, right? And we have people that are claiming to, like, this is the truth. We have the moral high ground because we have the truth on our side and our math works out. And then you really just put a magnifying glass to it and it falls apart completely.
Yeah, I mean, those two equations being directly the same is crazy.
Let's take the time right now as we're at 4:29. We're going to switch over to Rockfin. The link is pinned at the top of the YouTube chat. We'll give you like another minute to pop on over there. The rest of the show will be done on Rockfin exclusively. Does anyone have anything they want to say to the YouTube audience before we switch over?
Yeah, thank you all for being here. Much
Yeah,
love.
yeah. Thanks for being here. Join us over on Rockfin for the rest of the gravy.
And if you had trouble following this, don't feel bad. I mean, I'm going to go back and watch this a couple more times. I mean, I've studied this a little bit already, so I pretty much got the gist of what he was saying, but I really want to get the lingo down. So, I mean, it's almost like learning another language. You really have to learn it so you can then speak it to the other educated people, and then you grab their attention. Just like Austin does.
Yeah, don't feel bad about it at all. This is the things that they intentionally hid from you and didn't want you to know, and it takes some time. And I know some people are like, "Oh, this is nerdy. It's too much. I clock out. It's almost boring. It's too technical." But really, it's not. Once you wrap your mind around it, it's very digestible. It's simple. the Earth doesn't move, that there's a preferred direction, this whole idea that there's a constant speed of light, and that there is no preferred reference frame is easily disproven with everyday technology. Thus, everything implodes in on itself from the heliocentric paradigm, going all the way back to Michelson-Morley. So I know a lot of people are like, this is so technical, but I think it's very important. I think that once you realize the importance of it, you'll understand why I thought it was important to bring him on, because Alan's crushing, doing tons of work. So shout out to Alan. I dropped his YouTube in the chat, so you should go show him some love. That's Space Audits on YouTube. Go sub to him and show him some love for all the work he's putting in. And we thank you guys for kicking it with us on YouTube. And the rest of the show will be on Rock Minute set to free. So everyone good?
Yep.
All right. Yep. Cool. Thank you guys for hanging out with us. We'll see you on the other side. And Alan, when you're ready, you can go ahead and pick it up. All right. Peace out, YouTube.
All right. Okay, so we'll be covering the history of the Sagnac effect, published in 1913, rotating interferometer device. So they were attributing this to a rotational effect, and it was co-opted within the relativistic means by Paul Levine using his metric that he derived to specifically account for angular momentum, because Einstein's metrics, or Einstein's default metric tensors that he used with general relativity don't accurately account for angular momentum on the small scale. So they had to make a special metric for it, so that they could do this to co-opt it, right? But even that metric, which I'm not even going to get into, is derived from a mathematical logic fallacy, essentially. So like even that's invalid on the face of it, But anyway, we'll continue on here. So a little visual representation of what the Sagnac device looks like, similar to the Michelson-Morley setup. It's just circular, so and rotating at the same time. And let's see here. So the Sagnac effect being linearized, we already covered with GPS. This was originally going to be an interferometry presentation, and then I started finding out so much about Sagnac and GPS and stuff that it became its own side thing. And then now I haven't merged the two yet, so that's why it's kind of... So Wang 2004, thanks Wang for linearizing the Sagnac effect, showing that it's not a rotational effect and that it absolutely falsifies special relativity and proves that there's a preferred direction, and that is facilitated by an ether wind relative to an ether vortex, which allows you to accurately measure the variation in the change of the propagation speed of light relative to how far away it is, or you are, from the axis of rotation of the vortex at the North Pole. The place that we're all allowed to freely go and visit and travel, that we all took field trips to when we were kids and stuff. We've all seen a lot of North Pole stuff, so we can definitely verify all that.
Yeah, I mean, that 24/7 North Pole live.
Yeah, exactly. So to take it back to the crux of the issue, without continuing on too far, like repeating myself, Dayton Miller here is where things really pick up, right? So the Michelson-Morley experiment they did a couple of times, didn't get the result corresponding to what they needed to prove Earth's orbital velocity. They said it was a null result, proved the invariant speed of light, and then further said it somehow proved Earth's orbital velocity through a mathematical extrapolation. But while all that was going on, your boy Dayton Miller over here was doing repeatable Michelson-Morley experiments analogous to the way that Michelson-Morley did it, and even improved upon it a little bit. And I'll get into that and what his data showed. So Dayton Miller conducted the most extensive experimentation using laser interferometry during the mid-1900s, conducting a total of 5,200,000 measurements. He was able to determine a direct cause and effect relationship with the speed of the ether wind and the movement of the sun and the axial tilt of the cosmic microwave background. And I'll explain how that ties in towards the end. The fringe shift pattern reached their minimum and maximum dimensions in accordance with the equinoxes. This is directly relating a translation of motion from the sky to the Earth. The subsequent Michelson-Morley experiments in modern times are trending towards zero, and only further proves Miller's hypothesis. As you get closer to the surface of the Earth, less motion will be translated than at altitude. He also made considerations for environmental factors of the apparatus, such as, is the apparatus enclosed? Is it in a basement? What shielding is available for it? How are you accounting for vibrational effects, et cetera, et cetera? So for this reason, Miller's later work consisted of measurements taken at altitude, which would allow him to make more consistent measurements of the fluctuation of the ether wind speed. And this is a quote from Miller in 1933. A very striking consistency of the principal characteristics for azimuth and magnitude, as though they were related to a common cause. The observed effect is dependent upon sidereal time and is independent of the diurnal and seasonal changes of temperature and other terrestrial causes, and is a cosmological phenomenon or cosmical phenomenon. It's Miller, 1933. So as the universe completes its yearly circuit around us on its 23-degree axial tilt around the CMB, that motion corresponds to the movement of the sun as it travels along its axis spiraling between the Tropic of Capricorn and Cancer, which produces our seasons. Okay, so
He only did 5,200,000.
Yeah, dude, only 5,200,000, and only addressed every rebuttal to his work while he was alive, and did experiments showing, rebuttals to go along with that, with what he was rebutting. Only 5,200,000 times, and then he died, unfortunately, so he had to stop doing it. Yeah, so Dayton Miller's controlled experiments. So between 1902 and 1933, this is just how accurate and diligent he was with his work. So he had a really sensitive app.
That's dedication.
Yeah, he wasn't messing around, man. He wasn't messing around.
Such a dude, such a legend.
Yeah. So the way that he would adjust for his mirrors, he came up with a system that was really precise. He basically had a really finely threaded screw that he could adjust like just by a 16th of a degree, and that would correspond, to a certain wavelength adjustment. So he could isolate, how much, he had a lot of error control in terms of like, is the mirror reflected at the exact angle needed to not produce, additional fringe and all that. So he had, a really precise way of determining that. He had weights that he would add to the spinning apparatus, so that if there wasn't any, so that the weight would always be proportional when it was spinning, so it wouldn't be out of sync or anything like that. He used materials that would account for vibrational effects. He used materials that guarded against electromagnetic effects, so that there wouldn't be like outside interference or anything like that. So like Zeeman and Stark effects, things like that. So evaluating the mechanical vibrations is what I was talking about earlier with the materials, what they're made out of. Let's see. Different heat sources. So when he was talking about the diurnal and seasonal effects and temperature not affecting it, what he would do is he would have different radiant heat sources and lights on the apparatus while he was doing the measurements and stuff, and he would see how that would affect the French shift patterns. And what he found was that radiant heat sources and all that didn't really affect it. So earlier, as he was saying, when his data is plotted against diurnal, seasonal effects and temperature changes, it doesn't show any cause and effect relationships or anything like that. And the biggest critique of his work is actually that he didn't understand temperature differentials and temperature gradients, which he not true at all. So he went through great lengths to explicitly account for these things, even including things like measuring the heat temperature of his assistant, while he's standing next to the device taking the measurement, just to see if like body heat temperature would affect it. I mean, this dude was not playing around with how precise he got with it. So evaluating environmental temperature effects. So yeah, he plotted all his data against diurnal and seasonal effects, and found no cause and effect relationships with that either. So just very diligent with his experimentation. I think we've seen some quotes from Witset's streams where, even Einstein says that Dayton Miller was the most. What did he say exactly? Do you know the quote I'm looking for off the top of your head?
Well, Einstein did say that if Dayton Miller's experiments hold true, then it will topple relativity from the throne as experiment reigns supreme.
Yeah, experiment reigns supreme, right? So a guy that did 5,200,000 measurements, and he wasn't, he didn't do these experiments and then go, oh, I proved relativity, guys. So.
Yeah, I mean, Einstein specifically said that if Dayton Miller's findings were correct, that relativity was wrong. That's fresh out of Einstein's own mouth. And of course, he only did it, like we said, like $5 million.
Yeah, absolutely. Repeatable and all that, and testable. So this guy named Robert Shanklin was brought in to discredit Miller's work 14 years after he died. While it should be noted, while Miller was alive, no one could refute his work. Every time somebody would criticize him or whatever, he would just do more interferometry experiments and then directly addressing their criticisms or variables that they say that he didn't account for, et cetera, et cetera. So while he was alive, he would just bang these out. That's why he did 5,200,000. Some people say that Miller was just a crazy man and that he did 5,200,000 experiments just to create a broad data set from which you could mathematically extrapolate anything from. And that's not the case. He was literally directly refuting people and being very diligent about it. He wasn't trying to do this out of spite, or you know what I mean. He was actually doing science. And being really diligent about it. So let's see here. So yeah, they brought in after Miller died and couldn't defend his work after 5,200,000 times. Shanklin, one of his former research assistants, was brought in to discredit him. And what he basically says is that, Miller didn't account for temperature differential variations in diurnal seasonal effects, which, he explicitly accounted for. And in Shanklin's own words, he explicitly says, well, I don't even have the data to make even make the claim that he didn't know, that he wasn't accounting for it correctly, but I'm going to go ahead and say it anyway. And then here's this math done by my research assistant, which based on incomplete temperature data, I'm going to show that Miller's work is invalidated. So really cool story. He didn't even do the math himself. He passed it on to his research assistant and then just told everyone that Miller didn't know what he was talking about after he died.
And of course, we just read the quote from Dayton Miller himself, specifically stating that he did, in fact, control for those variables to exclude them, the diurnal changes and the temperature changes. If you actually read through his writings, he specifically names like dozens of things he did to prove that it isn't because of radiant heat sources or temperature fluctuations based on the diurnal fluctuations. So
yeah, exactly. And Shanklin's paper makes no mention of when you plot Dayton's work against the sidereal effects. So, no criticism there or anything about that. Like just completely no way to address that. But he's fully well prepared to say that he didn't know how to account for temperature variations when he himself says that he doesn't even have enough of the data to make that assertion himself. And then after that, he got exclusive interviews with Einstein. He had some, he got some promotion like his career accelerated after this, right? After he discredited his boy, so he was given special status to character assassinate a dead man who refuted relativity 5,200,000 times. All right, so the Dayton Miller conclusion. So the Dayton Miller's work on the ether drift was conducted with precision and diligence and has been disregarded and omitted from the history of science, despite Miller's response to his critics and his consistent demonstration of the ether drift phenomenon, ether wind. He was viewed by Einstein. He was viewed as a threat by Einstein. And so they brought in Shanklin to discredit his work and all that. Shanklin cherry picked through the data. Like I said, he only selectively talks about the temperature fluctuation, doesn't even bring up the sidereal effects, right? So to give some context on what Miller was measuring here, here's his work. So the periodicity of the global ether drift from Dayton Miller's Mount Wilson ether drift experiments, the top graph plots the data from 4 separate months or epochs measured at different times of the year, organized by sidereal time, showing a definitive periodic curve. The heavy line is the mean of all 4 epochs. The bottom graph is plotted against data organized by civil clock time coordinates, so sidereal, rotation, daily, seasonal stuff. It is plotted here. Here plotted against the graph without the apparent periodicity. This demonstrates that the detected axis of the periodicity of the ether drift is the same for different times throughout the year, but can only be seen when viewed through a cosmological sidereal coordinate system. So plotted against the sky, plotted against regular temperature stuff, right? It's only showing fluctuations on a specific time during the equinoxes, specifically here. So here's another average of the same situation. So average of the velocity and azimuth of the global ether drift from Dayton Miller's Mount Wilson ether drift experiment, 1925-1926. The top graph, the average variation of the observed magnitude of the ether drift from all 4 epochs measurements. The maximum velocity occurs at 5 hours sidereal and minimum velocity at around 17 hours sidereal. When Miller's 1933 paper assumes Earth was pushing through the ether moving toward Dorado, near the southern pole of the plane of the ecliptic, the movement of the direction of the ether past the interferometer was directly opposite that towards Draco near the northern pole of the plane of the ecliptic, 17 hours right ascension, plus 68 declination. It is important there. It is important from a standpoint of his working theory to clarify the concept of net motion of the Earth versus the direction of the ether drift. However, if the ether drift itself is in motion, acting as a cosmic prime mover, the direction of the ether itself and net motion of the Earth would be identical though at different velocities. Bottom graph, average variation. The observed azimuth readings according to sidereal time. The graph uses the average data curve from figure 11 over here, published from Miller 1928. At the time was given with a different baseline average. The same graph is presented here, but for the first time using Miller's revised seasonal averages published in 1933, which helped define the axis of the ether drift. Oh, there's an axis of the ether drift. You don't say. Amazingly, the independent averages of the 4 epochs provided by Miller: February minus 10 degrees west of north, April plus 40 degrees east, August plus 10 degrees east, September plus 55 degrees east, together yield a mean displacement of 23.75 degrees east of north. This yielded together a mean displacement of 23.5 degrees. Or closely matches Earth's axial tilt of 23.5 degrees and can hardly be more than coincidental. And that's from Demio 2002, who was reviewing Miller's work, and these are his thoughts on it. Right? So this is from Miller's paper. This is a model that he constructed of the fluctuation of the ether. So of course he's interpreting it through the heliocentric paradigm, and that there's an Earth moving through, a stationary ether. And this is what he came up with, right? So the same model that they kind of give us, that, the Earth's tilted over here, it's tilted over here this time of the season, and it's tilted, in this direction, right? So I'll show you a representation of what that would look like on a plane here in a second. But let's see here. So yeah, to recap though, these fluctuation speeds, like on the equinox to the day, reaches its maximum and minimum dimensions when the sun is going to be either moving closer or further away in the equator, right? So in the northern hemisphere, when we're having our summer, the sun's moving slower, and when it moves further away, it has to move faster to maintain that 15 degrees per hour. That fluctuation in speed is facilitated by that translation of motion of the ether drift, and that is what ether wind, and that's what Miller is measuring. So Michelson-Morley didn't cover. So this is an independent review of Miller's work by Maurice Elias, who was a French physicist and economist, and he won a Nobel Prize in economics for some theory or equation he came up with to describe something. I'm sure it was very cool. But anyway, he did an analysis of Miller's work because, what was in contention with Shanklin saying that, temperature differential, et cetera, et cetera. So this guy did his own analysis, and concluded that Miller was correct, and that there wasn't a temperature, wasn't due to the diurnal seasonal effects, and it was indeed due to something corresponding to the sky. So finally, the figures changed gradually on one period to another. They attained their maximum dimensions at around September 21st, which corresponds to the autumn equinox, and their minimum dimensions on September 21st, corresponding to the spring equinox. They are therefore dependent on the Earth's position in its orbit around the sun, right? And I think that was a quote from Elias, right? So obviously globe lads, right? So stationary non-rotating plane, the last sentence would be rewritten as dependent on the sun's position along its ecliptic. So as it's, doing its thing, its speed will be, the ether speed measured will correspond to that to facilitate that motion. it'll all be aligned or whatever, right? So let me
It's almost like it's a ordered system or something.
exactly. Let me see if I can show this. Okay, so this is what that would look like on an STP. So using the Walter Bislin model with a topographical view over here, we got the sun doing its thing over top, doing its axial wobble, right? So the sun is what is because it's wobble, that's what creates the analemma, and that motion, right, is what's being measured by Dayton Miller, right? That speed fluctuation change. So the sun's doing its thing here. This is what it would look like on an STP with just imagine that ether wind speed fluctuation with the sun's movement is what Miller's measuring. So see how it's going in and out for the things or whatever, the seasons. So that's it has to change translational speed to maintain its angular 15 degrees per hour. That's what Miller's measuring. So just to end on the recap here. So this change, what's all being measured here. So this frame right here, again, this is what it looks like on our, our azimuthal grid or whatever, how we see the sun. This is what's happening in the sky above us. And the ether wind speed is following this. That's what Miller measured. So this model right here that he's showing about, the tilt of the earth and all this, it's the sun ecliptic is tilted. Its orbital path is what's tilted, not us.
And of course, because that's where they got the alleged tilt of the Earth, and then what debunked that even is the cosmic microwave background.
Right.
This tilt is far beyond a local effect. If it's the Earth that's tilted, it would only be locally seen, but it was observed way further out in the cosmic background, showing that this is actually just a celestial.
Exactly. So yeah, there's no reason why it would be axially aligned like that unless the universe was also, I don't know, translating its motion, from or its yearly rotation, right? Translating that motion down to us, having some sort of an effect. And at the end of the system, as it trickles down to us, the version that we get is a nice calm 1,000 miles per hour at the equator that varies relative to where you're at on the latitude coordinate system. And again, the coordinate system isn't indicative of living on a globe. You don't live on a coordinate system. It's just describing a location on the coordinate system, right? So, if that, don't let that be like a hurdle for you because of the way that they describe it, right? Like this is all stationary topographical plane. All right.
Yeah, like it always says, you can obviously live on a plane, then take the data and force it into a globe and transpose a globe onto the plane with a coordinate system. That's all they did.
Yep. All right. So that's all I got for interferometry, man. Appreciate it. Go ahead and stop sharing now.
And let me just add, obviously, Alan just crushed. Let me add one little piece. The people that don't know, Dayton Miller, he redid Michelson-Morley's experiment multiple times, just like he said. And then what he found was that the fringe shift detected directly correlated to the time of the year, the seasons, and actually the maximum and minimum fringe shifts would align perfectly on the equinoxes. There is no way to think that that's logically just some type of coincidence. That based on the equinoxes, right, the spring and fall equinoxes, that's whenever he saw the minimum and maximums of the fringe shift, which goes to show us, just like he just said, that actually it's a celestial phenomena that's translated down to the Earth, measured it continually, replicated it 5 million times. Elias then looked at it again. Of course, that's where you've heard the Elias effect. And then the fact that it changes relative to altitude correlates with Bob's findings of there being a change of the ring laser gyro relative to altitude, because you're having motion translated from the sky. That's where the actual force is coming from. And as you get closer to the sky, you get a different result. And you pick up a greater